Hello everyone, today I'm going to show you how to solve the linear differential equation with a constant coefficient using the Laplace transform. But first of all, you need to know the theorems of this LDE with constant coefficient. Okay, the theorem is you can find it in the module page 114. Okay, the theorem is like this. Laplace transform of the yt is equal to ys. Okay, and the Laplace transform of the y prime t equal to s ys minus y0. And then the Laplace transform of y double prime t is equal to s squared ys minus s y0 minus y prime 0. Okay, so this is the theorems that you must remember. Okay, let's say if you have the question like dy over dt plus y equal to 3 and the initial condition is y0 equal to 0. Okay, so what is the step 1? The first step to solve this one is you need to transform the differential equation for both sides. Okay, what do you mean here is this one dy over dt we transform into Laplace transform of dy dt is y prime, okay, y prime t, and then plus with Laplace transform of y because of the y here, so is Laplace transform of yt equal to 3, so it's Laplace transform of 3. Okay, so if you look at this Laplace transform of yt, Laplace transform of the y prime t, so we use this one. Okay, so you will have the s ys minus y0. Okay, then what about the Laplace transform of yt? Yt we use this one, so that is the ys, so plus ys. Okay, and then Laplace transform of t. If you refer to the table of Laplace transform of the a, it would be the 1 over s. So it is 3, so it's 3 over s. Okay, so this is the first step. And then the second step is the initial condition. You need to consider the initial condition y0 equals 0. When t equals 0, y equals 0. So you can substitute in. So you have the sy0, sys minus this y0. So you substitute y0. Then plus with ys equal to 3 over s. Okay, this is step number 2. And then step number 3. So you can simplify. So you have the ys, right? So you take out the ys, so you just simplify. So you have the s plus 1 equal to 3 over s. So your ys equal to 3 over s plus 1. Okay. So what is next? So you have found out you find the solution for the ys. Now you need to change to the yt. From the s domain change to the time domain. So you need to do the inverse Laplace transform to find the yt. So step number 4, you find the yt. So it means that you have the inverse Laplace transform of the ys, you obtain yt. So here either you can use the transform of integral or you can use partial fraction expansion. Now I use the partial fraction expansion, so we can have the 3 Okay, let's find for the A and the B and to solve the question. So now you have A s plus 1 plus B s. So assume the s equal to -1. So you have 3 equal to negative b. So b is -3. And then if you assume the s equal to 0, so you will obtain a equal to 3. So inverse Laplace transform of this one, you will obtain inverse Laplace transform of the a is 3 over s. Okay, b is -3, so you have minus 3 over s plus 1. And therefore your yt will be 3 minus 3s power negative d. Okay. Okay, let's look at another example. We have b y double prime minus y prime equal to exponent t cos t. And initial condition is 0 for y0 equals 0 and y prime 0 equal to 0. Okay, so how to solve this question? So again, if we use the theorems, okay, remember we use the theorems. Y double prime 0, you obtain s squared ys minus s y0 minus y prime 0. So this is the one we are going to write here. So you have the s squared ys minus s y0 minus y prime 0. Okay, so this one is the y double prime. Okay, then minus y prime. Y prime is sys minus y0. And then this one equal exponent t cos t. So what is the cos t? Okay, cos t is referred to as over s squared plus a squared, right? But now your t is 1, so it's 1. Okay, in this case, you have the exponent t. Exponent t means that it's a shift. So shift is, you have to shift how many? Shift 1, so you get s minus 1. So as exponent t here, you obtain cos t here, you obtain s over s squared plus 1, right? But if you have the exponent, so it means that we change this one into s minus 1 because the exponent t, and then this one also exponent 1, s minus 1 for the exponent is the shifting plus 1. Okay, and next one, the second step, so you need to know the y0. Y0 is 0 0 and y prime 0 is equal to 0 also. This one is given in the question. This one is given in the question. And then you just substitute the y0 here and the y prime 0 here, and then you got the value. Okay, so from here we'll have the s squared ys, sy0 you obtain 0, y prime 0 also you obtain 0, minus with s ys, y0 obtain 0, so you have the plus 0 equal to s minus 1, this one also s minus 1 squared plus 1. So when you simplify, you have the ys And then you have s squared minus s. Okay, so ys equal to s minus 1 over s minus 1 squared plus 1, and then you have to divide with s squared minus s. Okay, so this one you can, okay, I straight away do it like this. S, so this one I just factor it out, s minus 1. So you can cancel out. So you can cancel out this one. So it equivalent to 1 over s minus 1 squared. So it's s squared minus 2s plus 2. Okay, and then multiply with the s. Okay, now you find the ys. From the ys, you can find the yt by inverse the ys. You obtain okay, you can use the partial fraction expansion to find the composition to find the a, b, and c. I think this one should be no problem to you. Okay, so you have 1 s over s squared minus 2s plus 2 equal to a over s plus bs plus c over s squared minus 2s plus 2. Okay, then you get 1 over this one, a s squared minus 2s plus 2 plus bs plus c multiply with s. So you have as squared minus 2as plus 2a plus bs squared plus cs. So this equivalent to, you collect all the s squared, so you have the a plus b s squared, then followed by s, so you have plus c minus 2as plus the last one is 2a. Then you compare the s squared. So compare the s squared, so means that it's this one. So it's a plus b. But when you look at you compare the left hand side and the right hand side. Let's say the right hand side is a plus b. But what about the left hand side? Is there any s squared? There's no s squared, means that it's 0. Okay, then you compare with s. S is this one, so it's c minus 2a. And the left hand side also nothing, so we left it 0. And then you compare again with f power of 0. So we have 2a. But we do have 1 here, so it's equal to 1. So from here we know that the a is equal to 1 over 2. Then we find the other value, b. Okay, a is equal to 1 over 2. You can find the a plus b equals 0. Means that it's from the equation 1. So b actually is equal to negative half. And then what about c? So c minus 2a equal to 0. And then your a is half. So c equal to 2 half is equal to 1. So c is equal to 1. Then you substitute back into the equation just now. So your a is half, so you have the half of the per s, and then plus with b. b is negative half, So negative half s plus c. C is 1 over s squared minus 2s plus 2. So what is your yt? Okay, yt here, this one you get half of 1 over s is 1, okay, plus with okay, and then this part is based on the second shift theorems. Okay, and then you obtain the inverse Laplace transform. Okay, how to obtain the s squared minus 2s? Okay, roughly you can say that s minus 1 square. Okay, let's say s minus 1 square, you will obtain s square minus 2s, which is we can obtain this one exactly the same. But you will have the plus 1 because s minus 1 square, right? So you have the plus 1. Actually, this plus 1 is an extra and we don't need it. Okay, we don't need it. Maybe I shouldn't say don't need it. Actually, okay, sorry, I should restart again. Okay, how to get s square minus 2s plus 2? Okay, if you want to solve using a second shift theorems, we have to do like s square minus s minus 1 square. So s minus 1 square, roughly we can have the s square minus 2s plus 1. But in your question is we need the 2. So we need to plus 1 again in order to obtain 2. Okay, so it means that this one is plus 1. So we write here s minus 1 square plus 1. Okay, and then how about the numerator? For numerator, again, since the denominator we use the s minus 1, so of course on top we also need to use s minus 1. Okay, let's try and see. Okay, negative. Okay, from here we have negative half s plus 1, right? Negative half s plus 1. Sorry, negative half s plus half. Okay, negative you multiply in, so negative half s plus half. But in your question, you need is plus 1, so not enough. Not enough, right? So we need to add in some more. For easiness, we minus 1, and we minus half, and then plus 1. It's still the same, and we obtain the answer here. The same answer here, the same value. So we can write this one actually is what? Actually is plus half. So negative half s minus plus half plus half. Okay, this will equivalent to half of, okay, this is from here, half of the 1 over 2 plus, okay, if you look at here, s minus 1 actually is a shifting, so it's a exponent t, it's a shifting, it's an exponent t. So you inverse Laplace transform, you still remember the previous lesson. So this one you will obtain negative half s plus half. Then we left this one is s squared plus 1. Okay, now we can solve again. Half plus exponent t. We have a negative half, so we take it out the negative half. And then inverse Laplace transform of s over s squared plus 1. And then plus with half. Inverse Laplace transform again is 1 over s squared plus 1. So can you clearly see now? So this part will be cos. Okay, so you have negative half cos t. This part is cos. And then plus with positive half. This part is sine. So it's a sine t. Okay, that's all. Thank you for watching. And if you want to do exercise, you can try another example again for dx over dt minus 2y equal to sine t. And dy over dt minus x minus y equal to 0. And x 0 equals 0, y 0 also equals 0. So you can try to solve this question. Thank you for watching.